Welcome to Spring LIB.
Hi there. Today we're going to be working on a really pretty interesting problem about viruses and silicone. In this problem, we're going to be modeling this virus and this piece of silicone as a mass on a spring. So in the picture that you can see up in the top left, we've got the mass of silicone attached to a spring and the mass of the virus that can or cannot be on top of the silicone. The first thing the problem wanted us to do was find a clean expression for the frequencies that these are going to vibrate with and without this virus. So the first thing we do is just look up the straightforward frequency equation. I'll write that in green on the other side. We have frequency for the silicone, just the silicone alone, is going to be equal to 1 over 2 pi times the square root of spring constant K divided by the mass of the silicone. Now we're going to look for another expression that has to do with the mass of that virus, or rather the mass of the virus plus the mass of the spring. So for that, we'd have the frequency for both the silicone and the virus is going to be equal to 1 over 2 pi times the square root of K. And this is actually going to be the same K, because if you look over at that diagram, we're modeling this as if there were just another mass added on to the same spring, divided by the mass of the silicone plus the mass of the virus. So these are the expressions that we're going to be working with. What we're looking for ultimately is an expression that involves this F as V divided by Fs. So if we come over here, we'll just go ahead and divide them. FSV divided by Fs is going to give us 1 over 2 pi on top times square root K over Ms plus Mv. And then on the bottom, we're also going to have a 1 over 2 pi, and then another square root, and this one's going to be K, but just over Ms. We can do a lot of cancellation here. We can cancel out this 1 over 2 pi. We can cancel out this K, which is really pretty nice. And it's going to leave us with an expression that looks like this. It's going to be the square root of of Ms brought up from the bottom, divided by Ms plus Mv. If we divide all the terms in here by Ms, that's going to be equal to 1 divided by the square root of 1 plus Mv divided by Ms, which is just what the problem was looking for us to get. Cool, so that's part A. If we look at part B, it asks us to do some calculating, some interesting stuff with this particular formula. So part B, we have the mass of the silicone shard is going to be equal to 2.1 times 10 to the negative 16th grams. So this is a very, very small piece of silicone. The frequency that it vibrates at without the virus is going to be equal to 2 times 10 to the 15th hertz. And then once you add on the virus, it's going to be equal to 2.87 times 10 to the 14th hertz. Cool. So at this point, I think it's best typically to start by rearranging your equation for what you want before you plug things in. So if we do a little bit of moving things around, we can get the mass of the virus is going to be equal to the one frequency squared over the other frequency squared minus 1 times the mass of the silicone. And that's just real simple algebra. This ends up being approximately 9.99 times 10 to the negative 15th grams. So incredibly tiny. The last thing that it asks us to do is to change that into femtograms. We just realized that femto means 10 to the negative 15th, and we say that that's going to be equal to 9.99 femtograms. I hope having me help you through this is